Thank you for granting us this interview. Please introduce yourself and let us know a little bit about your background and the work you're currently involved in.
Hi, my name is Marcel. I'm a senior technical staff member with the IBM Java Technology Center. I work out of the IBM Toronto lab, which is co-located with the IBM Just-in-Time compiler team. I've been working on Java and compilers for System Z now for over 10 years. My main responsibilities, amongst other things, is the development of the IBM JVM for System Z, which includes ZOS and Z-Linux. So I look at Java on System Z as a workload optimized system. So I look at performance of Java, I look at the hardware-software interface. I also look at legacy modernization and interlanguage communication, which are particularly important on a platform that has 45 years of history. And of course I look up and down the stack at the operating system and at middleware and how they interoperate with Java.
Could you please talk about some of the key performance improvements in the upcoming IBM JDK 7?
Sure. There were significant improvements in the J9 R26 Java runtime environment that ships with Java 7, WebSphere 8, as well as Java 6.01 on System Z on ZOS. A lot of those improvements came from the just-in-time compiler and an aggressive set of new optimizations that were put into the Common Optimization Framework. Beyond this, we've done significant work for IBM hardware exploitation of Power 7 and Z196. We also moved towards a smaller object model. This results in an improvement in footprint as well as a better data locality when running Java. And finally, we did a lot of work to improve startup time for large applications like WebSphere Application Server in our shared classes and ahead-of-time compilation framework.
IBM has made significant investment in mainframe technology. What are some of the value adds in IBM Java runtime towards System Z exploitation?
After being introduced over 45 years, IBM System Z remains IBM's premier enterprise computing platform. With over 12 years of Java on the platform and a pervasive presence of Java across IBM middleware on the platform in IMS, Kix, DB2, and obviously WebSphere Application Server, Java continues to be a first-class citizen on the platform. With innovations such as decimal floating point, large pages, compressed references, we've seen a tremendous amount of co-design between the JVM, the hardware, the middleware, and the operating systems. Beyond this, more recently we saw more than 70 new instructions added to the Z196 architecture. All of those instructions were co-designed with the Java team. In particular, a lot of the instructions were designed around primitives that are very Java-centric, such as the Java Util Concurrent framework. Beyond this, the JVM ships with a lot of extensions that are tailored towards exploitations of the qualities of service that come with ZOS. So for instance, JZOS is a lightweight batch launcher that is packaged with the JVM that really enhances Java Batch significantly on the platform. There's also extensions and wrappers for things like JAS, so access to RACF and Top Secret, access to SMF records, ZOS Logger, and Workload Manager, for instance. What these really do is they give Java applications running on ZOS the ability to be platform neutral, but still have the ability to go off and exploit ZOS qualities of service to give you optimal resource exploitation on the platform.
Do you see any challenges with Java scaling up in leveraging multi-core systems?
Multi-core certainly has a lot of potential to disrupt the stack that we've known over the last 2 decades. For instance, whereas in the past you could write an application that performed less well on today's hardware and expect that application to inherently get speed up as new generations of hardware come along, if you prescribe to that philosophy today, you probably would not succeed, you would fail. Silicon technology is simply not providing single-thread performance improvements the way it has before. And customers are still expecting to see improvements in throughput and response time in their software stacks. So what that resulted in is a lot of innovation is being pushed up the stack. For instance, you're seeing the hardware-software interface go to places that it typically would have shied away from in the past. And what that means now is that you're putting more emphasis on the need for compilation or recompilation of your applications to exploit those innovations. Java here has an inherent advantage given that it's dynamically compiled. So it always is fully aware of the platform that it's running on and can as such take advantage of the latest greatest innovations on that platform. Beyond this, we can expect to see sloppy programming, whether intentional or not, become much less tolerated. Performance tooling to identify opportunities for improving code. Beyond this, for enabling tuning and performance optimization of applications is going to become more critical. And of course, the languages will need to evolve to allow for more performance tuning as a result. Java may be a little bit more challenged here because the tendency in Java is to abstract away things like memory management and data I/O mapping. So these are areas where other languages have an upper hand potentially in an environment like this. I mean, more generally speaking, when we look at workload optimized systems, there's a bit of a dichotomy that evolves there, where being platform agnostic while trying to be specialized for a specific workload on a specific stack are really two opposing constraints or requirements. We'll have to see whether Java has the right flexibility and elasticity from a performance perspective to really enable specialization of the stack. How much of that can be hidden in the runtime environment and how much of that's going to need to be in the Java language itself, remains to be seen, I'd say. Other things about multi-core, looking at scalability, looking at concurrency programming, parallel programming. Java is well equipped here, given that it's been designed as a multi-threaded language from day one, and we do have tools like Java Util Concurrent that are really going in the right direction. So I think Java is well positioned from that perspective. So lots of good, some areas for improvement. I'd say there's a lot of potential for things to evolve here, and necessity is the mother of innovation, so stay tuned.
Any advice for our readers and young developers who aspire to pursue their career in Java?
Absolutely. I would say that performance analysis and performance tuning skills are only going to become more and more critical as we need to tap into application code to find the new performance opportunities. I'd say gaining a better understanding of how the runtime environment works and how to exploit it is going to be critical. So a good metaphor here would be, a good race car driver always knows how his or her car works best. And so understanding what's under the hood and how to exploit it to get optimal performance is going to be critical. Beyond this, stay up to speed on latest, greatest practices. Tools like Java Util Concurrent are only going to continue to evolve, and you should anticipate that you're going to need to know the latest, greatest on these frameworks to be able to really provide great performance for your applications. And finally, be curious, explore, and have a lot of fun.